Hi everyone, in this video I'm going to be introducing you to what's called trigonometric graphs. Okay, this is all to do with trigonometry, sine, cos and tan, and it's how the calculator gets its numbers when you do trigonometry. Okay, we take it for granted when you do SOHCAHTOA and even sine rule and cosine rule that you just type in 8 times sine 35 and you get an answer out. Okay, but this is looking in detail at how the calculator works it out, where does it get the numbers from. Okay, so there's a little bit of note taking. You're going to be drawing some graphs as well today because the calculator gets its answers from a graph, okay, or from 3 different graphs. There's a graph for sine, a graph for cos and a graph for tan, and those graphs, or the numbers that give you the graph, are stored extremely accurately in the calculator. So whatever you type in, the calculator has an answer for sine, cos or tan of that, okay? Or even if you were doing sine minus 1 to find an angle, or cos minus 1 or tan minus 1, okay? It's the same 3 graphs, okay? Now, why do you need to know this? Well, normally if you're doing trigonometry, you don't, because you would take the answer that the calculator gives you. But there are instances where the calculator only gives you the first solution it finds off the graph, but you actually need a different solution. Okay, normally what the calculator does is give you the first answer it finds, but we'll see when we draw the graphs that there are other answers. Okay, we'll look at more detail in that in a different video later on. In this one I just want to show you how you draw the graphs themselves and for you to be familiar with the shapes, and well, there's various different things I need to show you. Okay, so if we look at, first of all, if you put a heading sine graph, okay, sine with an E is there's the full word, okay, shortened on a calculator to, I know you lot call it sin, but it's sine anyway. Okay, now a couple of things on this graph then. Our axis, our x-axis is different angles you can have. Okay, so what I've gone up to 360 positive and down to minus 270 only because I ran out of grid squares. Okay, you can go down to minus 360 if you like. There's no point going further than that because the graph does repeat itself, okay, as you'll see in a minute. Now the y-axis, which is sine x, only needs to go up to 1 and down to minus 1 because sine never goes higher than 1 or lower than minus 1. It only goes between the two, which is why when we did trigonometry back in year 9, and sometimes you put your numbers in the wrong way round and you'd get a maths error, it's because you were trying to ask the calculator to work out something that isn't on the graph, and so it gives you an error because there is no solution for what you're asking it to do. Okay, so what you'll need a calculator for this. So once you've got your axes drawn, go and find a calculator. I'll pause the video until you've got one because we'll work together on this. Okay, and the first thing I want you to do when you've got your calculator is to type in, and I'll just sort of do some scribbling up here. We'll start from 0. So I want you to type in sine 0 and press equals. Okay, so the sine of 0, if you press on it, it should come out as 0. Okay, so 0 degrees, we don't put the degree sign in, but for 0 degrees, sine comes out as 0. So I'll plot that on my graph at the origin. Okay, then we'll plot sine 90. So if you type sine 90, so we've jumped to 90 degrees now, sine of 90, you should get 1, which is up there. Okay, then we move on to sine 180, and you'll get 0 again. So back down here. So it goes 0, 1, 0. Okay. Maybe we'll predict what's coming next. Sine of 270, type it in, is minus 1. So that's down there. And then sine 360, I'll see if I can squeeze it in at the top here. Sine 360 should come out as 0 again. Okay. Now, that doesn't mean that the graph zigzags up and down like this. Okay. You must have done graphs in physics by now, wavelength and amplitude and that sort of stuff. Okay, so hopefully you'll realize that this graph actually follows a really nice curvy shape. okay, which is a little bit tricky to draw with this pad, but I give it a go. Not my finest bit of work ever. Let's try that again. You need to join these up with a really smooth curve. This is a little bit better. Make sure you hit all your points. And what you've got there is, I mean, in physics you'd say it's one complete wavelength, because we've got back to the start. Because if I kept going here, all it would do is just repeat again, carry on going up. I won't actually draw it in, but that's what it would do. Okay. But because that is one full wavelength, it means that I can carry on this way without actually typing it in. You can type it in if you want, look, but I need to go down. So sine of minus 90 is minus 1. Then it comes back up. Then it goes up to 1. Alright, so the minus degrees, I know that sounds a bit bonkers how you have minus degrees, but later on in maths you might need to do this. When you're working with minus degrees, it's exactly the same shape. And it would come back, if I had enough room, it goes back down to minus 360 goes to 0. Okay, so that's a sine graph. Now, what's happening when you're typing in numbers? So, say I wanted to do sine 75, and 75 is what, roughly by there. Say I typed in into the calculator sine 75 degrees, the calculator would give me 0.96592. Okay, how is it working that out? Well, off this graph, look, it's coming up here, across here, and it's reading off this value, 0.96592. And the calculator can do that for any degrees, any angle you type in. Okay. If I ask it to do sine minus 1 of, I don't know, let's pick a number between 0 and 1. So if we say, what is sine minus 1 of 0.7, okay, we get my calculator. So sine minus 1, shift and sine of 0.7, and the calculator says that that is 44.4. Okay, 42 dot dot dot. How is it doing that? So what the calculator is doing off this graph is that it's finding 0.7 on this axis, and it's saying, well, what angle does that match up with? And that matches up with 44.42. That's where a calculator gets its numbers from when you're doing trigonometry questions. Okay, so that's a sine graph. You'll need to learn the shape of a sine graph, because this is not always on a calculated paper, so you won't always have the luxury of typing in the values to draw the graph. So you will need to learn this at some point. Okay, might be worth, if you've got room, putting on the 2 examples there of going up from 75 degrees and across, or across from 0.7 and down. And you can muck around with minus ones if you want. It'll just give you very big numbers over here. Okay, more detail on that in the next video. Right, let's move on then. Now then, exactly the same axes. So redraw the axes, pause the video to give yourself a bit of time to draw them. This time we're going to do cos. Okay, so up to 360 positive, down to minus 270 negative again. This time we're going to type in cos of different angles. So cos of 0 on your calculator should come out as 1. Now remember, last time we started at 0, this time we're starting at 1. Cos 90 comes out as 0. Cos 180 is minus 1. And what you're doing here is you're actually making the exact same shape of graph, but sort of shifted sideways a bit. Transformed, we say. Okay, translated would be a better word even than that. So it's exactly the same shape. Cos 270 is 0. And cos 360, again, 360 degrees, it completes one full wavelength, so we get back up to 1. And the shape of this graph this time then, so cos, the only difference between cos and sine is basically where they start from. Sine starts from 0 and goes up. Cos starts from 1 and goes down. Oh, I hate drawing with this pad, it's bad enough writing. There we go. This is where having a smartboard would be better. Okay, so it's the exact same shape, just shifted sideways. Okay, look, if I copy and paste this, copy and paste, I should be able to get this to line up, I mean, almost perfectly. Okay, so it's the same shape, just shifted over a bit. And then in the negative values, then it just does exactly the same thing. It's a mirror image, and the fact that it's symmetrical and has a mirror image is really important when we come on to solving problems. Okay, so this is a Cos graph. You get it from typing in values, but you'll need to learn the shape. Okay, it starts from 1 and goes down, but again, look, it only goes between 1 and -1. So if you ask the calculator to do cos -1 of 1.3, okay, so cos -1 of 1.3, it'll just give you a maths error because 1.3 is up here and the graph never goes up there. Okay, but if you ask it to do cos -1 of 0.5, okay, so cos -1 of 0.5 comes out as exactly 60 degrees. So if there's 0.5, this is, it didn't go perfectly there, 60 degrees. Okay, works exactly the same way as the sine graph did. You can type in an angle and it'll give you a number between -1 and 1, or you can do cos -1 of a number between 1 and -1 and it'll give you an angle. Okay, depends what you want to do. But that's a cos graph. Okay, very similar to a sine graph. Now the last one is the graph of tan. Tan's short for tangent. Okay, now tan looks nothing like sine and cos. You'll need the same x-axis, the same degrees, so from -270 up to 360, equally spaced, make it quite big. Okay, but there's no -1 and 1 this time, and that's because tan is not limited between -1 and 1. Tan goes up to infinity and down to -infinity. Okay, tan is really, really bonkers compared to sine and cos. Now if we start typing in some values like we did before when you're ready, if I do tan of 0, I get 0. Okay, that's not unusual. But if I type in tan of 90, what you'll get is an MA error. Okay, now you haven't done anything wrong. What's happening is that at 90 degrees, tan doesn't exist. I'll explain more in a second. But if you type in tan 89, okay, very, very close to 90, you'll get 57.29. Okay, so the tan of 89, I'll put it here so I've got a bit of room, 57.29. Okay, so there. If you type in tan of 89.999999, which is really, really close, you get in a couple of million, 572 million, something like that. Okay, so we're definitely not limited between 1 and -1. Now what's actually happening is this. So the graph climbs slowly at first, and then as you get closer to 90, let me get rid of that little 89 marker, as you get closer to 90, the tan graph gets steeper and steeper and steeper and steeper. Okay, eventually going up to infinity. But it never actually gets to 90. You can't have tan 90, it's impossible. I'll show you why in a second. Okay, but what happens is the graph doesn't just disappear and never come back. On the other side of 90, it reappears down here. And the best thing I can compare this to is like on Pac-Man when you go off the top of the screen and you reappear at the bottom. And it comes back and it goes back to 0 again at 180 degrees. Okay? Then it does exactly the same thing. It shoots off upwards at 270 up to infinity. Okay, it's not very well drawn, and reappears the other side. Okay, it goes to 360, and you have this repeating pattern of shooting off up to positive infinity and reappearing again at negative infinity, go through 0 and do it again. And what we have is a special name. So on your graph, what you'll need, if you put some dotted lines in at 90, like vertical, and another one at 270, and they are what's called an asymptote. Okay, it's not just a tan graph where this happens, it happens in other graphs as well. It's a point on a graph which is impossible to actually get to. Okay, now it's spelt asymptote like that, and the graph never touches the asymptote. Okay, it can get very, 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 very close to it, but never touches it. But you can reappear on the other side. You can jump and come out the other side. Now, why can't you have tan of 90? So let's draw a little triangle. Now, tan, if you go back to SOHCAHTOA, tan is O over A. So if I put my angle here, theta, and a right angle there, because it's trigonometry, there's the opposite, there's the adjacent. Okay, so tan theta is O over A. Now, as you make the angle bigger, and therefore the triangle gets taller, whoops, O divided by A gets bigger and bigger, because O is getting massive compared to A. Okay, as you could end up with like 3,000 divided by 2. Okay, for a very, very steep angle. I mean, that would be a tan of 89 something degrees probably. Okay, and you can get even taller again. You can go up here. Okay, maybe now this is 5,000 and this is 2, and so tan is 2,500. This angle theta can get very, very close to 90. It can get to 89.9. Now the triangle would be ginormous, look. An angle of 89.9, remember that's almost straight up. The computer's not going to let me draw it straight up. So this would still make a triangle. Eventually, at some point up there, miles and miles above where the screen cuts off, these two lines would meet and it would make a triangle. And the height would be ginormous and the width is tiny, and so tan is a massive number. But when you get to 90, if you try and make the angle 90, now it's not a triangle. Those two lines will never meet, now they're parallel. Okay, you can't have a 90 in the bottom right and a 90 in the bottom left and have a triangle. That doesn't make any sense because the lines will never meet. So that's why you can't do tan for an angle of 90 degrees. Okay. It also explains why the graph goes into such ginormous numbers when you get close to 90, because what's happening is the triangle's getting super duper tall. Alright, so there's our tan graph. It does the same in the negatives. So it goes down, gets very, very close to minus 90, but never touches it. Reappears up here. Goes down through 180 and disappears off down at minus 270. So there are more asymptotes. Okay. Basically every 180 degrees you get one. And it just repeats like that forever, tan. So tan is mad really in terms of a graph. It's the most bonkers graph you've probably ever drawn. Okay, so that's how you get your graphs of sine, cos and tan, which you'll need to learn, because sometimes you have to draw them in an exam and you don't have a calculator for it. Okay, sometimes they're drawn for you. Sometimes you get given on a calculator paper, and that's easy enough because you can just plot them just by typing in sine 0, sine 90, sine 180. Okay, and that's a little introduction to trigonometric graphs.